Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss redox reaction as the basis for titration. Titration meaning you might be knowing titration is the process in which a strength of unknown solution can be known by the known solution. Unknown solution can be known by the unknown solution. What? A strength. A strength, as for example, for acid, unknown, you are not knowing the strength of the acid, but you can know the strength of acid with the help of known strength of base, with the help of indicator. Okay, indicator tells about the end point. When acid will neutralize the base, that time this indicator will change its color and it will tell the end point. Okay. Then redox reactions also function as the basis for the titration. In acid-base system, we come across with a titration method for finding out the strength of one solution against the other using a pH sensitive indicator. Similarly, in a redox system, the titration method can be adapted to determine the strength of a reductant or oxidant using a redox sensitive indicator. The usage of indicator in redox titration you can understand with some examples. Now, first example I am telling you. First, I will tell you three examples, three different type. Then first, I am telling you in one situation, the reagent itself is a colored indicator. Reagent itself is a intensely colored, that is, for example, permanganate ion, KMnO4 potassium permanganate, that you can tell there permanganate ion. Okay, it is a colored pink color. Its color is pink. Here MnO4 minus 1 minus means permanganate ion acts as the self indicator. Question is asked. The visible end point in this case is achieved after the last of the reductant is oxidized and the first lasting tints of pink color appear at MnO4 concentration as low as 10 to the power minus 6 mole decimeter cube minus 3. Decimeter minus 3, or you can tell 10 to the power minus 6 mole per liter. Then here you have to understand reductant. Here which reductant? Then maybe ferrous ion, maybe chromate ion. Okay. Then this reduction or reductant, you can tell. Reductant are example ferrous ion and chromate ion. Then meaning of reductant means reducing agent. You know, reducing agent means here for the meaning you should understand reducing agent. For the reduction, reducing agent is required. For oxidation, oxidizing agent is required. Okay, then reducing agent will lose the electron and oxidizing agent will take the electron, don't forget. Then here ferrous ion, Fe2 plus ion, and chromate ion means not chromate ion, oxalate ion, C2O4 2 minus, oxalate ion. Actually, this titration I am talking about potassium permanganate versus chromate ion. Chromic acid also you can tell. Chromate ion C2O4 2 minus. Then actually reaction will take place between permanganate ion and chromate ion. Not chromate ion, oxalate ion C2O4 2 minus, oxalate ion. Then permanganate color is pink, and at the end point pink color indicator, this I told you reagent itself function as a self indicator. Then here this ferrous plus ion or oxalate ion is oxidized, and the first lasting tints of pink color appears at very low concentration of MnO4 minus, means permanganate ion. Concentration may be very less, 10 to the power minus 6 mole per liter. This ensures a minimal overshoot in color beyond the equivalence point. The point, equivalence point means the point where the reductant and the oxidant are equal in terms of their mole stoichiometry. Okay, then here you have seen that this was the redox reaction. MnO4 minus means permanganate ion and oxalate ion. This titration was between permanganate ion versus oxalate ion. Okay, then this was the redox reaction. Then here in redox reaction, that this reagent permanganate was self-indicator. Then this color developed due to the redox reaction. Okay, means reduction, oxidation, reaction, redox reaction. Second example I am telling you, that if there is a no dramatic auto color change, as with MnO2 titration, there are indicators which are oxidized immediately after the you can say last bit of the reactant is consumed. Here from outside you have to put during the titration from the outside you have to put you can say suitable indicator, as for example diphenylamine function as a indicator. Okay, then here I told you there are indicators which are oxidized. That indicator will be oxidized. Okay, means they will lose the electron. Oxidized means indicator will lose the electron. That indicators which are oxidized immediately after the last bit of the reactant is consumed. Okay, reactant will consumed. Then when it will be in the last, when reactant is going to be finished, that time it will oxidize, you can say indicator like diphenylamine. Okay, then this is the important things, and it will produce color. Okay, and its color will be blue color. The best example is offered by, you can say, chromate ion, which is not a self-indicator but oxidizes the indicator substance diphenyl just after the equivalence point to produce an intense blue color, thus signaling the end point, that end point has reached. Blue color coming means end point reached. Then here when chromate ion you are using, that time diphenylamine is used. Then chromate ion oxidizes to whom it oxidizes diphenylamine indicator, then it is also redox reaction. It is also redox reaction, okay, because chromate ion is oxidizing diphenylamine, okay. Then here also due to change of you can say these things oxidation is this diphenylamine electron, there will be change of electron, diphenylamine. Chromate ion will oxidize, means who will lose the electron? Diphenylamine will lose the electron, okay. Then here and chromate ion will take the electron. Then this is a redox reaction. Then due to this process, when this diphenylamine is indicator, when it will oxidize, then color will change. Its color will become, after oxidizing, its color will change blue color, okay, and that means end point is reached. Third example I am telling you, this example is restricted only to iodide ion. It is used in case of iodide ion. Then third example I am telling in details. There is yet another method which is interesting and quite common. Its use is restricted to those reagents which are able to oxidize iodide ions. As for example, cupric ion, Cu2+, that is called cupric ion. Reaction will take place like this: 2 cupric ion plus 4 iodide ion, 4I, okay, 2Cu 2 plus 4I means iodide ion. It gives cuprous iodide, Cu2I2, cuprous iodide. Means now here Cu was in +2 state, now in Cu2I2 Cu became +1, means a change in oxidation state, and I minus was there, 4I minus, then now it lost the electron and now it converted to iodine, solid iodine, but it will in the vapor form, okay, not a solid, in vapor form, I2 vapor it will form. This method relies on the fact that iodine itself gives an intense blue color with a starch. It gives iodine, what is formed during the reaction, it will react with the starch, if a starch is there, and then this will, it was actually iodine is, its color is blue, okay. Then during the reaction blue color will develop, and if in the solution a starch is there, then it will react with a starch, okay, and blue color will disappear. Then it happens at the end point. That's why when blue color, up to blue color titration is going on, and in the end blue color develops, blue color comes during the reaction, okay, and the end. And if a starch is present after blue color, starch is given near the end point, starch is added, indicated, not in the beginning like other titration. Then here iodine and starch will react, and iodine will disappear. Blue color disappearing means reach the end point. But here one condition is there, okay, that iodine and thiosulfate ion, here you should understand, actually during the thiosulfate will be in the burette, Thiosulfate will be in the burette, and in conical flask, cupric ion will be there. Cupric ion, okay, maybe CuSO4. That is a copper sulfate. In that copper is cupric ion, Cu2 plus, and in that this potassium iodide you have to add. Potassium iodide you have to add. Okay, purpose is there to add the potassium iodide. Then here you should understand that iodine, iodine actually it is insoluble in water. Iodine, during the titration, iodine will develop. Okay, iodine will develop, and because in this reaction potassium iodide is used. In this titration reaction, potassium iodide is used. Okay, then that cupric ion and iodide ion both reacts, and it forms iodine. And this iodine actually it will react with a starch. Starch is added, I told you, near the end point, and this iodine, blue color of iodine will disappear. That is the end point. Here now understand a little more. Okay, this method already told you relies on the fact that iodine itself gives, and iodine itself gives an intense blue color. With a starch, it will give blue color. Okay, with a starch, and has a very specific reaction with thiosulfate ion, which too is a redox reaction. Here that a starch, iodine and a starch both will react first things, and has a very specific reaction with thiosulfate ions, means S2O3 2-, which 2 is a redox reaction. This is also redox reaction. Okay, means iodine will react with thiosulfate. Iodine formed during the reaction that will react with thiosulfate. Thiosulfate is in burette. Okay, and it forms 2 iodide, 2I plus S2, S4O6 thionate, that is called thionate. Iodine plus thiosulfate, when both will react, it will form iodide ion plus thionate ion, means S4O6 2-. Iodine, though insoluble in water, it will not dissolve in water, remains in solution containing potassium iodide as Ki3. Because you have used the potassium iodide, then potassium iodide plus I2, iodine, it forms Ki3. It forms Ki3. Okay, then iodine, it is insoluble in water, remains in solution as potassium iodide as Ki3. Okay, because I2 plus Ki, it will form Ki3. On addition of a starch, I told you that a starch is added near the end point. On addition of a starch, after the liberation of iodine from the reaction of cupric ions and iodide ions. Already told you, when cupric ion and iodide ion, when both will react, then iodine will liberate. Only in the beginning I told you. Then iodine will liberate. It will form iodine vapor. Then in that situation I am talking about, on addition of a starch after the liberation of iodine from reaction of cupric ions on iodide ions, an intense blue color appears. This color disappears as soon as the iodine is consumed by the thiosulfate ion. Because thiosulfate ion you are adding drop by drop, and this iodine will be consumed with thiosulfate. Reaction will take place. Iodine plus, I told you iodine plus thiosulfate means S2O3. Iodine plus 2S2O3, it will form 2I, means 2 iodide, plus S4O6, 2 minus thionate ion. Then this thiosulfate ion will react with iodine vapor, which is produced with iodine plus starch. Okay, this blue color was developed. Then now this iodine is consumed. Okay, blue color, this color disappears as soon as the iodine is consumed by the thiosulfate ions. Thus the end point can easily be tracked, and after that we can do the calculation. Okay, then this I have told you. Here also it is the redox reaction. Then here two main things you have to understand, that this type of titration, that is restricted only with iodide ion. Okay, only with iodide ions. Then iodide ion can be, you can say, oxidized with the help of cupric ion. Okay, now in all like this reaction, all titration is not used. Only that in the case of iodide ion, which is going to be oxidized by something like that cupric ion I told you, there it is used. And then after this iodide ion, after oxidation, it produces iodine vapor, and this iodine vapor, near the end point we are adding the starch. Then it will develop blue color. It will develop blue color, and that blue color will disappear when thiosulfate will be added from the burette. Okay, and that disappearance of this blue color tells about the end point. Okay, then this I have told you, that redox reaction as the basis for titration. In all the things, in all three examples what I given, everywhere redox reaction was going on, everywhere, in all three. Then redox reaction is the basis for the titration. Okay, this is very clear, because many reaction depends upon in that wherever color is changing, there electron is going to be changed. Always keep in mind, electronic position will change, and electronic position is changing means redox reaction is going on. Okay, now I am going to discuss that is the another important things, that is the redox reaction and the electrode process, redox reaction and the redox reactions and the electrodes process. This is new for you. Now listen carefully, all things will be cleared. Okay, here first you have to understand the electrode. What is the electrode? Okay, actually this will be you will know more in higher classes. Now 12th also it is there. And then here what happens, first you have to understand the electrode. What is the electrode? Electrode is a metallic strip or metallic rod. Okay, then this metallic rod has a natural tendency. Two types of tendency it has. First I'm talking about first tendency is that some metals has tendency to lose the electron when it is in contact with the solution having the same cation. As for example, zinc rod, Zn metal, when you will dip in the solution of ZnSO4, okay, and other copper you take, other electrode, this actually metallic rod is called electrode. Then it is a two types. Then first type I told you that it has tendency to lose the electron. Metal will lose the electron when it will in contact with the solution containing the same cation, means Zn in ZnSO4. Then ZnSO4 in solution it will be in the form of Zn++, that is a zinc ion plus sulfate ion, SO4 2-. Then zinc sulfate is in the solution in the form of zinc ion and sulfate ion. And Zn rod, when if you will introduce in the solution, then Zn will you can say dissolve, and Zn rod will form Zn ion plus 2 electron. Last class I told you half reaction. Then loss of electron is called oxidation. Don't forget. That's why this you can say this electron, it is losing 2 electron. Okay, first to keep, I will come again this point. Zn will dissolve and it will produce Zn++ plus 2 electron, half reaction. Okay, and then this Zn ion will go to the solution. Then now Zn concentration will increase, because in already ZnSO4, Zn was there. Now this Zn rod again produced some Zn ion, and Zn ion concentration will increase. Okay, now what will happen? Other side you can see copper rod is dissolved in copper sulfate solution. Then copper sulfate solution also in water it will be in the form of copper ion and sulfate ion, cupric ion and SO4 - in solution. Then what will happen if actually both rod, zinc rod and copper rod, copper in copper sulfate, I hear Zn in ZnSO4. Then if both rod will join to each other, means Zn and copper if will join and you can say through ammeter or galvanic meter. Okay, means from Zn you have joined with galvanometer one point, and from again galvanometer to copper. Okay, you have joined. There is a connection from between the Zn and copper through galvanometer or ammeter. Okay, galvanometer actually it will read the volt, and ammeter will, you can say, tell about the current. Any one, either galvanometer or ammeter you can use. That both will be connected through ammeter, we consider ammeter. Okay, it measures the current, and this two solution, copper sulfate and ZnSO4, you have taken in separate beaker, Zn in ZnSO4, copper in copper sulfate. Then now through one U tube, you will take one U tube, and in that you will take one you can say KCl solution, saturated KCl solution you will fill in that U-tube. This is called salt bridge. Salt bridge. It will, the shape will be in U-tube. Then this will connect both solution. Both solution will connect ZnSO4 and copper sulfate. Then in this U-tube you will fill the saturated KCl solution and agar again is the, you can say, chemical that you have to fill it. That will actually, it will somewhat just like a jelly it will form. Then it will not allow to fall the you can say KCl solution. It will not allow to fall the both end. Agar will be there in U-tube, both end. Then it will not allow to fall the KCl. Okay, KCl solution, that is saturated solution. But it will allow to go the ions. Both end it will allow to go the to pass the ions. Ions can pass. Okay. Then now suppose this U-tube you have used. Through U-tube both solutions are now joining, connecting ZnSO4 and copper sulfate. That this after arranging this you can say diagram, or you can tell all set, it is called actually you have made Daniel cell. This is called actually cell. What you have formed, that is called cell, Daniel cell arrangement. Then now here this is just like a diagram. I will try to send it. Then now this is the, you form the cell, Daniel cell, Daniel type cell. Then Zn in ZnSO4 one rod is there, copper in copper sulfate other rod is there. Then I was talking about the electrode. What is the electrode? Then it is actually metal strip or metal rod. Then it has two type of tendency. First tendency is that some metal has tendency to lose the electron when it is dipped in the solution having the same ion. Example I told you, Zn in ZnSO4. It will lose the electron. Then loss of electron is called oxidation. Loss of electron is called oxidation. Means here oxidation will take place. Okay. And this is you can say one type of electrode. And second type of electrode, here this metal has a tendency to take the electron. Okay, opposite character. It has tendency to take the electrode. Then here, first what I told, that is called anode. Anode has, that metal is called anode, which has tendency to lose the electron. That is called anode. And other, which has tendency to gain the electrode, is called cathode. Anode is negative charge, cathode is positive charge. In galvanic cell, what we form Daniel cell, Daniel type of cell, that is the galvanic cell. Okay. Also called voltaic cell. Or galvanic cell in the name of scientist. Then what is the electrode? I told you. Then all metal have, you can say, this type of tendency. Either they will lose the electron or other may have tendency to gain the electron. Then now here you can understand what is happening. In the first case, this ion formed Zn dissolved and given the Zn plus ion. It went to the solution. What about the electron? It had given 2 electrons. Each atom will give 2 electrons. Then this electron, what will happen? That through the metals, actually metal rod will be dipped in the solution. Then that's why inside Zn ion gone. But this electron through the wire which you have connected to the copper metal through ammeter or voltmeter. Okay, this electron will go to the copper ion. From Zn side it will go to the copper. From Zn rod it will go to the copper rod through the connecting wire. Okay, then now this process, one more term I am telling you, that tendency to lose the electron is called oxidation. Oxidation potential. Tendency to lose the electron is called potential, which has tendency to lose the electron is called potential, which because it is oxidation, that's why it is called oxidation potential. And a reverse case which has tendency to gain the electron, that is called a reduction potential. Then here copper has tendency, reverse type of tendency. It wants to take the electron. It wants to take the electron. That's why copper is cathode. Then what will happen? That electron went from Zn and it came to the copper metal. Then copper metal is dipped in the copper sulfate solution. Then copper sulfate solution means Cu++ is there, SO4 minus, 2 minus. Then this copper cupric ion, because it has 2 positive charge, quickly as soon as electron will come on the surface of copper ion, then it is dipped in the solution. Then as soon as it will reach near the solution, then copper ion will be there, Cu2+. Quickly it will take that electron, 2 electron it will take. Then another half shell reaction will take place. Another half shell means reduction half shell, that is Cu++ plus 2 electron. Now it will give copper metal. Then see, first half reaction took place near the Zn and another half reaction took place near the copper. 2 half shell reaction took place. Because both have joined, then now net shell reaction you will get. Already I have discussed in the last class. Okay, then Zn is liberating the electron, giving the electron, and copper is taking the electron. Then on copper they are taking the electron, Cu++ plus 2 electron, and copper metal will deposit on the copper rod. Then copper sulfate which was present in solution, that cupric ion, that Cu2+ is depositing on the surface of copper metal. Then slowly and slowly all copper sulfate in that cupric ion was there, that will deposit on the surface of copper metal. Okay. Then here a reduction is going on, and potential tendency to gain the electron, that is called reduction potential. It has natural tendency to gain the electron. Then this tendency to gain the electron is called reduction potential, because reduction process is going on. Potential involved in reduction process, that is called reduction potential. And here oxidation, because it lost the electron. Then here potential also developed, but this potential developed during the oxidation. That's why it is called the oxidation potential. Then at the zinc electrode, oxidation potential, and at the copper electrode, reduction potential. Then which one is more? Suppose generally oxidation potential will be more. Just like water flows from high to low, like that way here current will flow from higher oxidation potential to lower reduction potential, from higher potential to lower potential. Then suppose oxidation potential is more and reduction potential is less, then current will flow, electron will flow from Zn to copper. Electron will flow from zinc to copper, but current will flow in a opposite direction. current will flow from opposite direction, opposite of flow of electron. Don't forget, direction of flow of current will be, you can say, opposite to direction of electron. Actually, how will be circuit completed? Upside electron went from Zn to copper. Then it is not complete. Then what happens now? This, see the role of salt bridge. Salt bridge. Okay. Ammonium nitrate is also used as a salt bridge. Ammonium nitrate and potassium chloride, KCl. Generally these two are used. Others are also there. Then here that now through salt bridge, what will happen? Because Zn metal dissolved and it produced Zn ion. Then Zn ion is more. Already ZnSO4 was there, the Zn plus plus SO4 minus minus, it was neutralized. But now this Zn ion went to the solution. Then alone Zn ion can't leave. Zn2 plus is there. Only one ion can't leave. It required negative ion. Then this sulfate ion from the copper side, because copper ion used there. See the situation. Copper ion, cupric ion used up. Then now sulfate ion was there. That sulfate ion will come this side through salt bridge, ZnSO4 side. Solution it will come. Then that Zn ion which was alone, and this sulfate went, sulfate ion SO4 2 minus. Then now there again it neutralized Zn plus 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 SO4 2 minus. Then now you can say this sulfate ion SO4 2 minus, this is the ion, negative ion, it passed through salt bridge. Then now circuit is completed. Okay, this is actually direction of flow of current. Flow of charge is also called current. Flow of electron is also called current. Okay, and flow of charge in solution is called current. Actually, in metal, current will flow because electron flows through the metal. Solid metal, electron flows. That is also called current. But in solution, ion will flow. Ion will flow. That is the flow of ion in solution is also called current. Okay. Then now I have told you here that oxidation process is also going on. Reduction process is also going on. Then half cell, if you will add, then it will be net cell reaction. Okay. And here again I want to tell you that if temperature you are a standard, I am talking about the standard potential, standard potential. The standard potential means always what I told you many times in previous classes, in previous chapters. Then here always temperature will be temperature, pressure, concentration. Three things should be fixed. Temperature, that is the you can say normal you can say temperature 273 plus 25 298 Kelvin. Okay, that temperature if you are maintaining, and pressure you are maintaining 1 atmospheric pressure. If pressure you are maintaining 1 atmospheric pressure, and concentration you are maintaining, concentration of the solution 1 mole, then that time this potential developed is called a standard potential. If concentration is 1 mole, pressure is 1 atmospheric pressure, and temperature is 298 Kelvin, 273 plus 25, 298. And three things if you are maintaining, then that time potential developed is called a standard potential. Here I want to tell you that reduction potential as considered as a standard reduction potential. according to IUPAC, International Union for Pure and Applied Chemistry, they have considered reduction as a standard. Hence, in a chart, you will find reduction. This reduction potential chart. This chart is there. In that, you will find reduction is considered as a standard, not the oxidation. Actually, oxidation potential is equal to reduction potential, but sign is different. Oxidation potential is equal to reduction potential, but there is a sign differences there. Okay. Both will equal, means positive, one oxidation potential, if it is a positive electrode potential, that is a sign of electrode potential, that is a positive, and negative sign is for cathode. Okay. Then reduction potential is considered as a standard. Always you will use, even in question they have given oxidation potential, then quickly suppose it is a plus, then now you can convert it as a sign, you change, plus will become minus or minus will come plus. Okay. Electrochemical series, in chart you will find that all metals they have arranged. Electrochemical series means they have arranged from, you can say, this negative to positive via zero. All metals, reactive metals, their potential has reduction potential has been arranged from negative to positive via zero. Okay, zero means here hydrogen is considered as a zero. Here you should understand hydrogen ion H plus, it will convert to H2, half H2. Hence 2H plus, 2H ion is there, 2 hydrogen, 2H plus, then it will give H2. And its potential has been considered as a zero. Simply, arbitrarily, its value has been considered as a zero. Then above hydrogen, all will be negative, and down it will be positive. Then each metal, it is arranged according to the, you can say, these things, more electronegative, that will be in the top, as for example in the case of lithium, then how actually it is written, I am telling you, it is written like that way, that lithium ion, after taking the because reduction is considered as a standard, then lithium ion Li1 plus 1 electron, it will take and it will convert to the lithium metal Li. Then what is the method to write? Li plus, and again 1 bar you write, okay, 1 bar, and then lithium. Li plus means lithium ion, 1 bar, 1 line you write, 1 bar, and after that lithium, means lithium ion is converting into lithium. This is the way to write. Then whose highest reduction potential is lithium, then it start with lithium only. Like that way, again slowly and slowly it is arranged. Who is next to lithium, it is written. Next to that again written. Next to that, just see the chart, you will see the electrochemical series, then you will come to know. Okay, like that way, most negative, that is the lithium, it will start from the lithium, and after that, which are the other, you can say, reactive things, after that it will arrange in just according to their value. According to the reduction value it is arranged, then it will come to the, you can say, zero. Okay, because minus is there, -4, -3, it will in the point also, -4.2, then maybe 4, then 3, 3.5, 3.5, 3.3, 3.1, 3, 2.8, like that way, 2.5, 2, after that again 1 point, like that it will come to 0. 0 is hydrogen, and after that positive charge will start, and the last will be the gold, Au 3 plus. Au 3 plus, bar you have to write, and then Au means metal you have to write end. First write iron, and after that in all cases same way. Iron you write first, oblique, you can say metal. Iron oblique metal. In general I told you. Lithium ion, Li plus oblique Li. It is the way to write. H plus, 2H plus oblique H2, or only one H you want to write, then H plus oblique half H2. But generally half H2, why will you write? Complete H2 write, then 2H plus oblique H2. And like that way, end I told you, that is the auric, Au3 plus oblique Au, because it is finally converting to the metal. Before auric, silver comes. Then before auric means gold. Before that silver Ag plus oblique Ag. This is the way to write. Then I have discussed, you can say, these things. Complete, just it is called, what I discussed, that is called Daniel type of cell, and in that electrode reactions are going on. Electrode process I have discussed. Okay. Then in every cell, redox reaction will take place in every type of cells. Any type, dry cell, lithium battery, any battery. Okay, lead sulfate battery, lead state battery, everywhere this redox reaction will take place. Okay, then I have discussed almost all things, and all thing I have discussed in 12th, same thing you will find. Then now again one thing I want to tell you, a node is positive charge. Why it is positive charge? Because on a node, in Daniel cell I am talking about, in Daniel cell or galvanic cell, or also known as voltaic cell, in that cell electrode is positive. Why it is a positive? Because electron is going from Zn to copper. Then because electron is moving, means negative is moving, then what is left out? If negative is going, then what is left out? Positive is left out. That's why it got positive. Then electrode will be positive. It is asked in the examination, advanced, IIT advanced. And cathode will be negative, because it is taking the electron. Then more electron will be collected. More electron will be collected. Electron means negative charge. That's why cathode will be negative and anode will be positive. Then almost all things I have discussed, and here this chapter also finished. Redox chapter now finished completely. Okay, next class I will start with next chapter. Then now you have to just again you read, understand, do practice. Okay, next class I will start hydrogen. Okay, thank you.